Welcome to another video. All right, so in this video we have this question about waves, that's electromagnetic waves. So we have a ray of monochromatic light is incident at the boundary between two transparent materials of refractive index N1 and N2. Now, we know that monochromatic light, okay, is a light which contains one color and one wavelength. All right, so the light is incident, okay, at the boundary between two transparent materials of index of refraction N1 and N2, just like what we have here. N1 is the index of refraction of the first medium. N2 is the index of refraction of the second medium. So we have the boundary, okay? Now the light, okay, the light passes from, is trying to pass from the dense medium into the what? The less dense medium. And now we want to find out the ratio N1 to what? N1 over N2. Now, first thing is, now this is a question under what we call refraction of light. You know, refraction of light is the bending of light at the interface or boundary separating two material media with different velocities of light, because when light passes from a less dense medium into a dense medium, you know, the light ray will bend towards the normal. But when it passes from a denser medium into a less dense medium, then it will refract away from the normal. Okay. So, but in this case, we have that the angle which the angle which the emergent ray makes with the normal, okay, is 90 degrees. So that's why we have what we call the critical angle. That's why we have what we call the critical angle. So now we are given the critical angle. Okay, we are given the critical angle. Now, based on what we have here, now critical angle is the angle of incidence. Okay, is the angle of incidence at which the refracted ray, okay, emerge tangent to the what? To the boundary. It emerge tangent to the boundary, which means the angle which the angle which the refracted ray will make with the normal will be what? 90 degrees. So we have the critical angle. Okay, we have the critical angle. Critical angle is the angle of incidence. Is the angle of incidence, okay, above which total internal reflection occurs. Okay, above which total internal reflection, okay, occurs. What does that mean? We know that total internal reflection occurs at a boundary, okay, separating two transparent media with no refraction. Okay, that means the light, the incident ray, that's the incident ray which makes an angle with the normal ray, okay, will be what? Will reflect, it will reflect back into the original medium. So in this case, so for critical angle, we know that when it comes to critical angle, the sign of critical angle would be equals to 1 over the absolute refractive index of medium 1 with respect to medium 2. And we can rewrite this as the sign of critical angle equals to 1 over N1, okay, over what? N2. So we then have our sign of critical angle to be the what? The ratio of, that's N2 divided by what? N1. So that's critical angle. So remember, we are giving the critical angle to be 80 degrees. So which means we're going to put 80 degrees, okay, as critical angle. So we have sine of angle 80 degrees will be equals to N2, okay, over what? N1. N2 over N1. So don't forget, this is the formula for critical angle. Okay, that's the formula for critical angle. So in this case, remember, we want to find the ratio of N1 to what? N2. So to calculate the ratio of N1 to N2, so we have to flip this fraction. So when we flip this fraction, so this turns to what? This becomes reciprocal. That's 1 over sine 80 degrees. So when we flip this fraction, this becomes n1 over n2 equals to the reciprocal of sine 180 degrees. So which means we now have our n1 over n2. So n1 over what? n2. Now let's get the value of sine 80 degrees. Now the value of sine 80 degrees is 0.985 approximately. Now what is now 1 divided by 0.985? Now 1 divided by 0.985, so we have n1 over what? n2 to be 1.015. Okay, that will be approximately 1.02. So therefore, the ratio n1 to what? n2 is equal to 1.02. And that is the ratio we're looking for. Bye-bye. Thank you.